Alrighty, so let's figure out now the electronegativity and Lewis structure for oxygen, or O2 gas. But first we're going to figure out the electronegativity of the pentanol molecule, and that's going to be a polar covalent bond, and that's because it has a carbon-oxygen bond, which is a 0.89 electronegativity, which is above 0.4, the cutoff for pure nonpolar covalent, and that gives us a right leaning right toward that carbon bond, which is on this side, electronegativity, because the hydrogen and carbon is a pure nonpolar covalent, and so that's what we end up with. So then we have the two oxygens, and we're going to end up doing so oxygen has 6 valence electrons, right? You add those up and you get 12, right? But you want 16 because you have to fulfill the octet rule. So we're going to have to put 2 double bonds, and we're going to put 2 electrons here instead of 6. So 2 pairs, or 4 electrons instead of 6, and 2 pairs. And so now we have 4 on each side, right? And then we have 4 in the middle, 4 going to both, right? 2 sharing from here, 2 being shared from here. And that creates 8 on 8 and 8, so that's the correct Lewis structure, with an electronegativity of 0, which gives us a pure nonpolar covalent 0. So the next one we're going to do is figure out CO2, and that's going to be C as a central atom, right? It's the first one you figure out, and O is going to be off to the sides, right? And what do we have total? We have 4 for C and 6 for O, so that gives us 16 total, and we want 24 because 3 that want 8, that want to fulfill the octet, end up at a total of 24 for an octet. And total. So we're going to have to put double bonds in here, just like we did before, and put 2 electrons on the top of both of these molecules. And now what do we end up with? We have 8 on the oxygen, 8 on the oxygen, and then carbon has 4, right? Because these bonds don't necessarily have to be 2 electrons per. So, hence, this is the structure. So, I should probably do it at the same time, but that's going to end up giving us a pure covalent bond, or polar covalent bond. And that is because the 3.44 electronegativity of oxygen minus 2.4455 equals 0.89, and that's the electronegativity of the bond between carbon and oxygen. So the next one we're going to do is H2O, which is O, fewest central atom, and hydrogen, and that's going to look like 2 electrons. So what do we want? We want 2 per the hydrogen, right? Because they want to fulfill their weak little mini octet, and just like lithium does as well. And they want 2, so that's going to be 4 plus the 6 that the oxygen, or the 8 the oxygen wants. So that gives us 12 for the octet. And what do we have total? We have 2 for hydrogens, and we have 6 for oxygen, so we actually have 8. So, Jesus handwriting. And how do we get 4 more electrons? So, oxygen is taking 1 from hydrogen, and it's also giving 1 to hydrogen. So hydrogen doesn't need anything more to fulfill its two wanted electrons. But oxygen is only, it only has, right, it wants 8, and here we only have 4. So we need 2 up here, 2 down here, and then that's the correct Lewis structure for H2O. And what are we going to have for electronegativity? Hydrogen, well, oxygen minus hydrogen ends up with a bond electronegativity of 1.24, which gives us a polar covalent bond, right? And that's quite polar compared to the other carbon-oxygen bond. All right.